Today we will do electric field lines. Let us write first the definition of electric field lines. The imaginary path which a very small positive test charge would move if free to do so, in an electric field is called electric field lines. Okay, so suppose if we have a positive charge Q here, we know that this positive charge Q, it will set up an electric field around itself in this region here. So now, for example, if we have, let us say, a positive, very small positive charge plus Q naught here. Now, if we allowed this positive charge plus Q naught to move, that means if it is free to move, it will move in a certain, let us say, path. In a certain path. So the path in which this positive charge plus Q naught is moving, that path will represent the electric field lines because of the electric field produced by this charge plus Q here. So I hope it is clear. Now let us go to the next topic. Now we will do properties of electric field lines. Let us write number 1. The electric field lines originate from positive charge and terminate at the negative charge or into a negative charge. Okay, so the electric field lines, they will originate from positive charge. For example, if we have plus Q here, so they will originate from here like that and so on, but they will terminate in a negative charge. For example, like this, they will come like this here, normal to the surface of the charge, like that. Okay, so let us see to the next point. Point number 2, the tangent drawn at any point. We can write the tangent drawn at any point on electric field lines gives the direction of the electric field at that point. So for example, if we have the electric field lines like this, Now if we want to know the direction of the electric field, let us say at point P, what we have to do, we just have to draw a tangent here, like this. The direction of the tangent will give us the direction of the electric field at point P. Similarly, for example, if we want at point Q, so we just draw a tangent here. Let us say this is point Q. So again, we draw a tangent at point Q, like this. So direction of this tangent will give us the direction of the electric field at point Q. Let's go to the next point. Point number 3. Electric field lines do not intersecting each other, do not intersect one another. So for example, let us take two electric field lines. Let us say this is electric field line number 1, this is electric field line number 2. Let us say they are intersecting at the moment at point A. Now we know that electric field is a vector quantity, so electric field lines must is a vector quantity. Now, for example, if we consider the electric field lines number 1, at point A, it will have two directions. One is along X, another one is along Y. So hence, if you look at point A, the electric field lines number 1 will have two directions. One is along X and one is along Y, which is not possible in the case of a vector quantity. It will not be possible for it to have two directions at one point. Similarly, if you look at the electric field line number 2, again, if you see at point A here, then again this electric field lines, it will have two directions. One is along X, another one is along Y, which is again not possible for the electric field line to have two directions at one point, that is at point A. Hence we can say that the electric field lines number 1 and number 2 will never intersecting each other. So we can say in general that electric field lines do not intersecting each other. Electric field lines do not intersecting each other. Okay, so number 4, let us say number of electric field lines. Number of electric field lines, okay, is directly proportional to the magnitude of the charge. Okay, so what does it mean? It means if the charge is very strong, the number of electric field lines will be larger, and if the charge is weak, that means the number of electric field lines coming from that charge also will be smaller. So we can say if we have a charge Q1 here, then let us say the number of electric field line which is coming from the charge Q1 to be N1. So N1 will be directly proportional to Q1. Similarly, if we have, let us say, charge Q2 here, so the number of electric field line, let us say N2, which is coming from the charge Q2, it will be directly proportional to the charge Q2. So therefore from here we can write, if N1 by N2, it will be equal to Q1 by Q2. Now let us go to the next point. Let us see the next point. The electric field lines are parallel and equidistant in uniform electric fields. number 5 or number 6, I don't remember exactly. Let us write number 5, whatever it is. So the electric field lines are parallel and equidistant in uniform electric field. So if the electric field is uniform, what happened to the electric field lines? They will be parallel and equidistant to each other like this. So we can say this distance between, let us say, field line number 1, field line number 2, field line number 3. So the distance between field line number 1 and number 2, let us say it is A. So therefore the distance between the electric field lines number 2 and number 3 also, it will be A. They are of equal distance. Let us go to the next point, that is number 6. Now let us talk about the electric field lines can never form a closed loop. Okay, electric field lines can never form a closed loop. Okay, we can write like that. As a line never start and end at the same charge, as the electric field lines never start and end, starts and ends on the same charge. Okay, so electric field lines can never form a closed loop, as the electric field lines never start or ends on the same charge. We never have a charge like this and electric field lines which is coming from the charge like that and then end up again on the charge. We never have this thing. This will not be happen. Okay. Similarly, if we have a negative charge like this, we will not have, let us say, a electric field line which is coming back to it like that, which is starting from itself. So we'll never have that. So electric field line never start or end at the same charge. They will start from a positive charge and end at a negative charge. Okay, so let us say the next point will be 7. Electric field lines have the tendency to contract longitudinally. Electric field lines have the tendency to contract longitudinally. That means, for example, if let us say if I have positive charge here and a negative charge here, let us say like that, then electric field line will come from the positive charge and entering the negative charge in that way. Now, suppose we know that this is positive charge and this is negative charge, then there will be a force of attraction between them. So let us say after some time this negative charge will move a little bit towards the positive charge. So in that way we could see that the electric field line number 1, it will be reduced in the length. So electric field lines in general we can say that they have the tendency to contract longitudinally along this side like that. But the length between plus Q and minus Q can be reduced. They can contract. Now let us go to the next point. Field lines, let us say, electric field lines have tendency to expand laterally. Number 8, electric field lines have tendency to expand laterally. That means, for example, if we choose a positive charge here and a negative charge here, let us say this is positive and this is negative charge, then the electric field line will come out in this way from the positive charge and they will enter the negative charge like that. Similarly, let us take few more electric field lines here. So this side also we will have like that. Then they will expand laterally like that. Now if we consider at region 1, region 2, region 3, we could see that the separation distance between these two field lines, let us say A and B, this is field line A, this is field line B, we could see that the separation distance between electric field line A and electric field line B at region 1 and region 2 and region 3 are not the same. We could see that the separation distance between the electric field line A and B at region 2 will be more than the separation distance between electric field line A and B at region 1. See, here the distance is more and here the distance is less. Because of this reason, electric field lines have the tendency to expand laterally. Whenever they get a chance, they will expand like that. They move a little bit away from each other. Next point, let us say number 9. The electric field lines leave or enter the charge surface normally. Electric field lines leaves or enter the charge surface normally. So for example, if we have plus Q here like this, so the electric field line, they will come out normal to the surface like that. Normal to the surface. Like we have seen in this case. They will come out normal to the surface. Also, if it is a negative charge, they will enter normal to the charge surface like that, and perpendicular to the charge surface. We will go to the next topic. Now we will do electric field lines, electric field lines due to some charge configuration. Due to some charge configuration. So we will see electric field lines due to some charge configurations. Number 1, let us say single positive point charge. Single positive point charge. So in that case, the electric field lines will look like in this diagram. All the electric field lines, they will come out from the surface of the charge normally. Now let us see number 2. Number 2, single negative point charge. single negative point charge. So in that case, we will have the electric field lines like it is in this diagram. All the electric field lines, they will incident normally on the surface of the charge. They will come and incident normally on the surface of the charge. Now number 3, we will have 2 equal and opposite point charge. 2 equal and opposite point charge, or 2 equal and opposite point charges here. In this case, 2 point charges. Okay, so we will have the arrangement of the electric field lines will look like we have seen in this diagram. They will all of them, they will come out from the electric field lines will come out from the positive point charge, and normally from the positive point charge, okay, normal to the surface of the positive point charge. They will come from here, normal to the surface of the positive point charge, and they will enter into the normal again to the surface of the negative point charge, as we have seen in this diagram. Now the next one will be 2 equal positive point charge. Number 4, 2 equal positive point charge, or 2 equal positive point charges here also. 2 point charges. Okay, so the diagram will look like we have seen here. In this case, we have seen the charge plus Q and the charge plus Q. The electric field lines, they will come out from both the charges and they will repel to each other. The one coming out from this charge, it will go that way, okay, and the one coming from this charge, it will go this way. So they will repel each other. And one more point here, the center end will be, the point end will be at the center between this charge and this charge. So let us go to the next point. Number 5, 2 unequal positive point charges. 2 unequal positive point charges. So in that case, we will have, the diagram will look like here. Here Q1 is not equal to Q2, so we have seen the electric field lines will be repelled to each other because both of these charges are positive, so it will repel. Now Q1 is not equal to Q2, and we have seen N is no more the midpoint between Q1 and Q2. As a result of that, we could see that the distance R1 is not equal to the distance R2 here. Okay, so now next we will see number 6, parallel plate capacitor. Parallel plate capacitor. Parallel plate capacitor. So here we will see that the electric field lines will be parallel to each other, okay, and the electric field lines will have equidistant to each other, and also the electric field lines will come out from the positive plate and they will enter into the negative plate. We finished the topic today. Thank you.